Okay, so one of the useful applications of probability trees is to understand what it means that a certain test, for example, test for a disease, has sensitivity and specificity features. Well, it is quite relevant these days because you could read and hear a lot about the coronavirus and all the tests or quick tests which are on the market, and they have certain specificity and specificity uh, marks. So let's see what happens when you test for a disease that affected 5% of the population. So because of measurements in the population, we know that right now this disease affects about 5% of the population. This is quite a large number, and we have a test which has a 90% sensitivity. Sensitivity tells us about the true positives, namely 90% of those who test positive are true positives, and specificity tells us that if you test negative, then you really are a negative. So 95% of those who get a result of negative in this test are definitely negatives. So let's see with concrete numbers what happens if you test positives. What are your chances that your positive is a false positive? Let's take a population of 10,000 people, because this makes sure that even the 5% is a big enough number not to have half individuals. And let's see, we have 5% of the population who carry the disease and 95% who are not affected. So 5% of these 10,000 is going to be 500. And the remaining are not infected. So that's 9,500. Okay, and then we test these people, all of these people with this test, and we know that 90% of those who are infected actually will end up with a positive result that gives us, because that we get because of the sensitivity. So 90% is going to be, which is 450 people, they are going to be true positives, meaning their test is positive and they are indeed affected by the illness. The remaining 10% are those, that's 50 people, who carry the disease. Remember, we are in this 5% branch, but they are going to end up with a negative, so they are false negatives. They carry the disease, but the result is going to be false because of negative. Okay, what about the 95% of the population who are not affected by disease? We know, because of the specificity of the test, that 95% of these people are going to be, that's this many people, that's going to be true negatives. So they are true negative, they are not affected, and their test reflects it correctly. Their result is negative. However, the remaining people, namely 475 people, are going to test, this is the remaining 5% of this 9,500, are going to test false positive. They don't carry the illness, but their test is going to end up positive. Okay, so what's the relevance of all these numbers? I know that my test is positive, and I want to know what is the probability that I am truly infected. As we know from probability calculations, that is going to be the so-called favorable case divided by all cases, which in this particular case means that you have to divide the favorable is the true positives, because I want to know what are the chances that I am really ill. I have to divide with the number of all those people who ended up with a positive result. So what are my chances of being positive if I have a positive result? So the false positives and the true positives come into the denominator as all cases. So that's these two numbers. And if you divide these two numbers, then your result is going to be 0.48, which means 48%. So basically the conclusion is that given a population where 5% of the population is affected by a certain illness, and given these quite seemingly high numbers of sensitivity and specificity of your test, your chances of being truly ill if you end up with a positive result is a bit less than 50%, which is, let's be honest, is quite low, so you don't want to risk being diagnosed positive with a 50% chance of being correct with your diagnosis. So this nicely shows that the number of true positives and false positives are very important indicators of how seriously you can take the results of these tests. In the next video, we are going to see how improving sensitivity and specificity changes, but also if you have an illness which affects an even smaller percentage of the population, like right now they say that with coronavirus it's about 2% of the population who is affected, then even a better sensitivity and specificity test can give you a lot of false positives. So we are going to discuss that.